Let us talk first about rotational motion. What is rotational motion? So, for that, we will consider for understanding rotational motion, we will consider a rigid body. Rigid body having many number of particles, and when this rigid body rotates about in some axis y dash, in that case each particle that constitute the rigid body will also rotate about the same axis during rotation. And what we see that each particle will have its path concentric to each other. So that means in rotational motion, all particles have concentric path. Also, they have same angular velocity. So, a rigid body in rotational motion is only considered if all its particles rotate in concentric paths and they have same angular velocity. Now, let us calculate the kinetic energy. Kinetic energy of rotating body. To obtain this, again we will consider a rigid body which is rotating about some axis y dash. We will consider the rigid body consists of n particles. N particles, each having different masses m1, m2, m3 up to mn. And these particles are at distances r1, r2, r3, rn at positions r1, r2, r3 rn respectively. Now, first we will calculate the kinetic energy of each particle. For that, we need to consider that as defined earlier, that each particle have same angular velocity, say omega. Then the velocity of this particle will be different. For example, velocity of first particle is B1 is equal to omega R1. Similarly, for second particle, velocity is V2 is equal to omega R2. Now we will calculate the kinetic energy of these particles. Kinetic energy of say first particle whose mass is m1 will be given by T1 is equal to half mv1 square, putting the value of v1 as omega r1 whole square, that is 1 by 2 m1 omega square r1 square. Similarly, kinetic energy of second particle T2 is equal to 1 by 2 m2 omega square r2 square. And in the same way, kinetic energy of nth particle is Tn is equal to 1 by 2 mn omega square Rn square, and hence finally kinetic energy of the whole rotating body will be given by the sum of the kinetic energy of all those particles that constitute the rigid body. Hence T is equal to T1 plus T2 plus dot 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 Tn, putting these values 1 by 2 m1 omega square r1 square plus half m2 omega square r2 square plus dot 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 half mn omega square rn square. Here 1 by 2 and omega square is common, remaining m1 r1 square plus m2 r2 square plus dot dot mn rn square. The sum terms inside the bracket can be written as summation I equal to 1 to n 1 by 2 mi ri square. So finally T is equal to 1 by 2 summation I equal to 1 to n 1 by 2 mi ri square omega square. This term, summation term inside the bracket, is defined as moment of inertia. So hence finally the rotational kinetic energy of a rotating body is equal to 1 by 2 I omega square, where I is called moment of inertia and is defined as sum of the product of mass of each particle and square of their distance perpendicular distance from the fixed axis. Fixed axis. This is moment of inertia. Definition of moment of inertia. Now, what is the physical meaning of moment of inertia? Physical meaning, or we can say physical significance. So, as we know that in linear motion, in linear motion, the uh, body has tendency to uh, avoid changes in state until any external force is applied. That property is called inertia. This is in linear motion. Similarly, in rotational motion also, in rotational motion also, everybody everybody has tendency to keep it with its initial state. So this is rotational inertia, and this rotational inertia is called moment of inertia. That means the moment of inertia has same role in rotational motion as similar inertia has in linear motion. And by definition, we have obtained that moment of inertia is defined as sum of product of mass of each particle and perpendicular square of perpendicular distance of those particles from the axis of rotation. Another term comes here, radius of gyration. This term is distance. Distance of a point in the rigid body from axis of rotation. Distance from the axis of rotation to a point distance from axis of rotation to a point in the body where whole mass of the body is concentrated. That means if this is the rigid body and it is rotating about the axis y dash, and this C is the point where the whole mass of the body can be considered to be concentrated. This distance, radius of this distance is called radius of gyration and is denoted by k. Now from the concept of moment of inertia, if this object is considered is consisting of n particles of different masses with their positions r1, r2 up to rn, then by the definition of moment of inertia will be defined as summation mi ri square I is equal to 1 to n. But from the concept of radius of gyration, if the whole mass is at c, the whole mass of the body, whole mass means m1 plus m2 plus the sum of all the masses of which this object is made, that is total mass m. So if we consider that the whole mass m, capital M, is concentrated at point C and this point is at a distance k from the axis of rotation, so in terms of k, the moment of inertia will be defined as total mass into the distance, square of the distance of that point where the mass is concentrated. So by definition, moment of inertia I is equal to summation mir square. In terms of radius of gyration, moment of inertia is mk square. Now the above equation I is equal to 1 to n m I r I square can be expanded as I is equal to m r m1 r1 square plus m2 r2 square plus dot dot mn rn square. If all particles have same masses, in that case we can write common letter m for the all mass. Since all masses are same, m is common, r1 square plus r2 square plus rn square. Now multiplying n above and dividing by n, in these terms n is the total number of particles. mn means mass of one particle into number of particles, that means total mass. R1 square plus R2 square plus dot dot Rn square pi by n. So if we compare this equation with I is equal to mk square, what we get, k square is equal to r1 square plus r2 square plus rn square by n, or k radius of gyration, k is equal to root under r1 square plus r2 square dot dot rn square by n. Hence, radius of gyration k, radius of gyration k of any body is equal to square root of mean of square of the distances of particles from axis of rotation.